Today's lesson is lesson 3.1, Slope from Tables, Graphs, and Points. Let's go ahead and get started with slopes from tables and points. To determine the slope of a line or the rate of change of a linear function when given a table or points in a line, we're going to use the formula m equals y2 minus y1 divided by x2 minus x1, or delta y, which stands for the change in y, over delta x, which stands for the change in x, where of course the variable m represents my slope. Regardless if you are given a set of points or a table, you can make a set of points from a table. Remember that a set of ordered pairs always is of the form, let me go ahead and make a parenthesis here, x comma y. And so my x value is always first, and then my y value is always second. So as you can see from my table, I could go ahead and make negative 12 comma 18 into an ordered pair, just as you see here. And I could also take 2 and 14.5 and make them into a formula into a ordered pair as well, or a point. I'm now going to go ahead and I'm going to use the formula to find slope, which is dividing the subtraction of the y values by the x values. Notice that I'm going to subtract y2, which comes from the second ordered pair, minus y1, which comes from my first ordered pair. The 1 and the 2 are subscripts, so we do nothing to the number themselves. They're just identifying which y we're talking about. The y from the second point, the y from the first point. They do nothing to the numbers 18 and 14.5. Likewise, on the bottom, in the denominator, we're taking x squared and we're subtracting we're taking x2 and subtracting x1. It is not an x squared, so it's doing nothing to the 2, and there's nothing that you're going to do with the 1. They've gone ahead here in the example, and they've actually done the subtracting to get this, which we can simplify in the calculator to negative 1/4 or negative 0.25. There's a difference between when we would use a fraction for our slope and when we would use a decimal. Fractions are good when we're going to graph. So in this unit, we will get into graphing, and it's very important to keep a fraction as your slope in your graphing. However, a decimal can be very important when we're looking at a word problem, because it makes more sense to think of things as 25 cents versus a fourth of a dollar. And so sometimes they're more practical. All right, let's go ahead and start with example 1. The table shows the linear relationship between X, the number of hours Sam's works each week, and Y, the amount of his weekly paycheck. So remember, in my table, if it is not stated for you in the description of the problem like it is here, remember the first column of your table is going to be your X values, and the second column of your table will be your Y values. The first thing we're going to do here to find the rate of change, because notice they're asking what is the rate of change in his paycheck, we need to pick 2 points, 2 ordered pairs. Now I would probably pick the first ordered pair from the table, which is 20, 230. And then I would probably skip the second point and go to the third point. And the reason for that is because the second point, as you can see here in the Y value, does contain a decimal. Although I could still use it, it's just going to be harder for me to do mental math if that's what I'd like to do. All right, I've gone ahead and done those, and now I'm going to go ahead and label them. Remember, always the first numbers are x's, and it's traditional to call the first one x1 and the second one x2. The second numbers inside of our parentheses are our y values. If you forget, remember, we wrote it down right up here, and you can always go back and check. Now, since the 230 y value is with x of 1, it needs to be y of 1, because we can't have a 1 with a 2. And then this The 345 needs to be y of 2 because its x is x of 2. If I were to switch this to x1, then this would switch to y1, this would switch to x2, this would switch to y2. It doesn't matter the order you pick them, you just have to label them. Now we're going to go ahead and we're going to plug it into our formula. As we are learning a new formula, it is always best to go ahead and to write the formula down. It's going to ensure that you memorize it. So the more you write it down, the more it gets stuck in your brain. Plus, the color will also help you to quickly substitute in the top. I know the two numbers with the purple underneath them need to be in my top subtraction. I need to put y2 first, 345, and I need to put y sub 1 second, 230. If I'd like, since I am substituting, I can go ahead and put them in parentheses. On the bottom, I'm going to subtract the x's in the same order that I did on the top. If I subtract in a different order, then I'm going to end up with a different answer. All right, now that we have everything substituted in, we can grab our calculator, or we can simply subtract in our head. 245 minus 230 is 115. 30 minus 20 is 10. I got 115 over 10. Because we are talking about work, it would probably make sense to go ahead and to change it into a decimal. So I'm going to go ahead and do that right now due to the situation. Now they want us to interpret the meaning of the rate of change within context to the situation. What does this 11.5 mean? Well, this is Sam's earnings. So this means that Sam earns $11.50 per hour that he works. All right, let's go ahead and do example 2. What is the slope of a line that passes through the points 60, negative 16 and negative 15, 19? The first thing you're going to do is label your x's. The first values in each of my parentheses are my x's. It is traditional to call them x1 and x2. The second numbers inside my parentheses are my y values. My y's take the subscript of their x. And now I'm going to go ahead and I'm going to grab my formula. And remember, since we are learning the formula, it is imperative that we write it before we start substituting. It helps us to memorize and it helps us to get it plugged in correctly. It slows us down. All right, then the 19 goes first and then the minus 16. This would be an absolute perfect place to go ahead and make sure that I'm using the parentheses. Let me make that look like a parentheses, but you could use the parentheses on the 19 as well. And on the bottom, I'm going to go ahead and subtract. Once again, I'm going to go ahead and use my parentheses. It helps me to see the double negatives, which of course are going to turn to positives, right? Minus a minus is a plus, minus a minus is a plus. Otherwise, I can just let my calculator take care of that as well. I'm going to go ahead and do that, and I got the fraction negative 7 over 15. Since there is not a word problem for this example, it would be proper to leave it as a fraction. Go ahead and try this. What is the difference between slope and rate of change? We did discuss this a little bit in class. All right, slopes from graphs. To determine the slope of a line or the rate of change of a linear function from a graph, we can use m equals rise over run. We can think of this as the change in y over the change in x, or we can also use the formula. Because remember, on a graph, you can find your ordered pairs. So sometimes it's important to use the formula. Sometimes the rise over the run, you'll find it to be a little bit quicker. When using the rise over run method to determine the slope of a graph, remember to read your graph from left to right. The first step is to select 2 points. Now, what you need to select are perfect corner points. They need to be points that are in the corner of one of the grid boxes. This one is perfect because it's the corner of this box. That one is perfect because it's the corner of this box. This point right here is not a good point because on its grid box, it is not in the corner. Let me go ahead and zoom in so you can see that a little bit better. This point would not be a good point to pick to do rise over run because it is not in a perfect corner of the grid box. These 2 points that they've picked for us are. All right, after we've picked our 2 points, we now need to start with the point on the left, count up positive slope or down negative slope. Maybe we should highlight those words. Count up. Oh, hold on. I wanted to change the color. There we go. Count up for a positive slope. Count down for a negative slope until you are at the same height as the second point. The number of units you counted up or down is the rise or delta y, the change in y. Step 3 is to count right until you arrive at the location of the second point. The number of units you counted to the right is the run or the change in x, delta x. Then you're going to go ahead and you're going to plug them into m equals rise over run and simplify. Let's go ahead and try them. Now here in graph 1, what I'm noticing is that this point isn't quite in a corner, perfect corner, where this one is. So instead of doing rise over run for this one, I am going to go ahead and use the formula. So I'm going to go ahead and say m is equal to, there we go, the subtraction of y2 minus y1 over the subtraction of x2 minus x1. I'm going to go ahead and I'm going to label my points. I'm going to go ahead and label them as x1, x2, y1, y2. Hola! Now I'm going to go ahead and substitute in my y's, and I'm going to substitute in my x's. Remember, what you might want to do is you might want to use your parentheses to help you in your calculator or in your substitution. I'm going to go ahead and subtract the numerator, which gives me 1.2, and subtract the denominator, which does give me, oh, that's not negative 5.3, it's just negative 5. There we go. I got distracted, which does give me negative 3. I am going to go ahead and divide this because we don't want to leave a decimal inside of a fraction, which gives me negative 2 over 5. I could have saved myself that from simply going straight to my calculator. I could have put this in, and my calculator, of course, will give me my simplified version. Now in this next one, I can go ahead and use the rise over the run. So I am going to go ahead and I'm going to pick 2 points. Here is a perfect point, perfect corner point, and here is a perfect corner point. So there they are. I'm going to start at the one on the left. So remember, you were always going to start over here on the left side, and we're going to go to the right side. So from this left point, I need to go up. And I simply need to count how far I went up. 1, 2, 3, 4. Oops. There we go. And now we're going to go ahead and we're going to run to the right. And we're just going to count it. 1, 2. And there's our slope. So our slope is going to be our rise, how in this case, how much we went up, over our run, which is to the right. I got 4 over 2, and since I went up and to the right, these are both positive directions. So everything is positive. 4 divided by 2 is 2. All right, our last example today is a graph that shows the linear relationship between the price of an item in US dollars and the price of an item in Canadian dollars on a given day. What is the rate of change of the price of an item in Canadian dollars with respect to the item's price in US dollars? Notice they're asking for rate of change. That's just another way of them asking to find the slope. Since it is a graph, ooh, what happened? We can go ahead and we can use the rise over the run. So once again, I'm going to go ahead and use rise over run. I'm going to pick 2 perfect corner points. I'm going to go ahead and pick this point, and I'm going to pick this point right here. I would run up because this is my point on the left of my graph, and then I'm going to run over to the one on the right. So let me count how far I went up. Be careful. Please remember to make sure that you're looking at the scale of your graph. This one is not going 1, 2, 3, 4. This one looks like it's going 20, 40, 60, 80. Did I go too far? I went too far. Hold on just a sec. I did go a little bit too far up. There we go. I'm going to stop there at 60. There we go. And my rise was up. Okay, and now I'm going to go ahead and run over to my point to the right. And let's count. Once again, we need to make sure that we look at the graph. It's not going by 1, 2, 3, 4. It looks like it's going by tens. 10, 20, 30, 40. So it looks like we've got 40, and we went to the right. Both of these are positive directions, so we're just going to do the rise over the run, and we're going to go ahead and simplify this to 3 over 2, or we could say 1.5. Remember, the reason to keep it as 3.2 would be graphing purposes, or there's not a situation involved. To change it to 1.5 would mean we have a word problem. In this case, we do have a word problem, so we would choose the decimal answer. What is the meaning of the rate of change when this applied context? Well, since we're talking about currency and we're talking about change, it means that an item would cost $1.50 Canadian per $1 US on this day.